Okay. Thank you guys so much for coming. I'm so glad to see so many of you today. It looks like I think almost everybody is here from both classes. I'll have to double check, but it looks like almost everybody. Okay, so which of the following is the most accurate statement about the regression results? So we want to make sure we read all of our statements. Notice that they gave us our regression model in terms of R. They gave us the R squared as well. They tell us that the value of R squared shows that there's a strong linear relationship between the length of the year and the mean orbital. So R squared is not going to tell us anything on its own. We always want to think about R squared combined with the residual plot itself. Okay. Part B tells us only about the residual plot. Okay. So for both A and B, we're considering in A R squared as well as the residual plot. In B, we're considering the residual plot. In C, they tell us the slope of the regression line, which would mean that we need to go back up to our equation in order to find the slope. And part D talks about the regression line underpredicts for a specific value. So we would want to find the value that they gave and see, do we fall above or below the line? If we're above the line, if our observed is above the line, we've overpredicted. If our observed is under the line, we I'm sorry, I said that backwards. If our value is above the line underpredicted. And if our value is below the line, our model overpredicted. Since I've screwed that up, let me say it one more time. So let's do it for not one of the values that's on here. Let's say that they asked us for 3,000. R equals 3,000. So we see that this is our observed value. Okay, it is well below our line. That means that our line overestimated, overpredicted what we actually saw. Okay, so that's the kind of statement that D is giving us. Did we overestimate or underestimate? But again, it's for a different value. Okay, so again, I didn't give you the answer there, but I just told you what to think about for each of those 4 statements. Okay, moving on. Okay. In the computer output, we are given that the dependent variable is Boston. The independent variable, therefore, is Atlanta based on this data. We're given our R squared and our adjusted R squared. Remember, we want to use R squared to get our R value from. We take the square root of that. So let's look at these statements. They give us statements about R and then interpretations. So again, if we want to know about R, we're going to take our R squared, square root it. We also need to decide whether R squared will always be positive. We need to be able to figure out whether our R is going to be positive or negative. We look to the slope of the line to determine whether or not it's a positive or negative relationship. So the slope of the line is the coefficient with the variable, this guy, and that's our slope. Because our slope is positive, our R value will also be positive. Positive slope, positive R value. Remember also that the slope, and this formula is given to you on your orange formula sheets that I passed out. The slope is R times S sub y over S sub x. So the R value helps us predict changes in the standard deviation. Whereas this is what I was saying in class earlier. Whereas the slope tells us for every change of 1 in the x variable, we expect a change of positive 0.55 in the y variable. The R value tells us what our change in standard deviation will be. So for every 1 change in our standard deviation for x will result in a change of whatever the R value is in our standard deviation for y. Okay? And I think that's all the helpful little hint you need in order to do number 18. Each of those statements requires you put together a lot of different pieces though. So of course, first is getting the r value, which again, r value is going to come from the square root of your r squared. You're also going to determine the sign based on the slope, positive or negative, and then you will have to figure out which of the interpretive pieces is correct with the number that you found. Okay. Moving along. Yes, sorry, Freddie. So that's one of the interpretations of R, but that actually wasn't one of the multiple choice interpretations that they gave you. So there's other pieces that R give us. You're going to have to figure out which of those is true. Okay. A residual plot, I'm not going to give you any helps there, you guys. That's straight out of your notes. Okay. The next question about car weights. Okay, the correlation between car weight and car reliability is negative 0.30, and the correlation between car weight and annual maintenance is 0.20. Two things that I want you to remember. You need to pay attention to the sign. You need to pay attention to the number itself. So each number really has two pieces of information. This guy is negative, and the absolute value of the relationship is 0.3. This guy is positive, and the absolute value is 0.2. Okay? So positive relationships mean that both variables increase together. As your x gets larger, your y gets larger. Negative means as your x gets larger, we expect the y to get smaller. Okay? And again, our values range from -1 to +1, but if we consider only the absolute value, the closer to 1, the stronger the linear relationship. Okay? That's it for that question. Here we have different statements about regression analysis. Statement number 1, a helpful hint, is that the sum of the residuals, by definition, will always be 0. That's something that wasn't in our notes today, but that's kind of part of the definition. By design, the sum of all the residuals will always be 0. There's no other way around that. Number 2 and number 3 are things that we talked about in class in your notes. Number 2 was the residual plot part of the notes, and number 3 was the outlier versus influential point to take a look at. Next question. This deals with linear transformations. It's important to note that doing a linear transformation does not change the linearity of the relationship. It preserves the relationship. Okay? So linear transformation preserves now other models for transformation are appropriate depending on the data themselves. If your data takes on a logarithmic function, then it's appropriate to use a logarithmic model to transform your data. If your data takes on a power type function, then it's not appropriate to use a logarithmic function, a logarithmic model. Okay. Next question. I know I'm running over here, so I'm going to wrap things up quickly. Here they ask us to figure out 2 points that we could eliminate and that would really affect our correlation coefficient. So if we want to decrease the correlation coefficient, that means make it less linear. So we want to first draw in our estimate of what would our line look like. And then we want to figure out which 2 points are closest to that line so that we get rid of them and therefore decrease the strength of our linear relationship. So again, two pieces to do here. We want to actually give ourselves a line, so we're not just eyeballing it. And then after we've given ourselves a good approximation of the linear regression model, we want to figure out which 2 points, or if the 2 points that we identify aren't there, which pair is the most appropriate to eliminate, which pair has the closest points to the line, and therefore by getting rid of them, we would do the most damage to our coefficient of correlation. The last problem for today, number 3, is a two-way table. This fits in with bivariate data because we're looking at two variables. It's really more of a probability, but it's good to keep in mind just the same. The thing you have to read carefully here is who is your total that you're looking at. The numerator is usually easy to find. The denominator is usually the tricky part. They tell us that 600 travelers have purchased airline tickets through the same travel agency. We see that 600 in our marginal sum total at the corner. They ask, what is the joint relative conditional frequency? So joint relative conditional frequency tells me that I'm only looking at a subgroup of that population. So I know right off the bat my denominator will not be 600. They ask for the female travelers to Asia. Female travelers to Asia. So of the people going to Asia, how many of them are female? You have to translate to figure out your denominator. Once you've done that, the problem is very easy. Okay, that concludes all the hints for today. I think that you should be in good shape for your homework. I will see you all in class tomorrow. Thank you.